Okay, so for this video, we're continuing our discussion of ray diagrams. I don't think I'm going to necessarily make every single one of these with you because I've already got them here on PowerPoint. You need to make them. I'm going to try and go through this quick so it's not a real long video, but you'll need to pause it in order to follow the instructions to make this diagram for yourself, because you can use these diagrams on the test. All right, so let's get through it. Pause it as you need. As before, set up your axes, X and Y, with the F and 2F, F prime and 2F prime, a lens in the middle. Make sure these distances are exactly accurate. Otherwise, this is a waste of time to you. Let's see what happens with an object at the focal length. So give this some given height, maybe like 3 squares or 1 inch. We're going to do the same as before, straight across to the x-axis, and then down through the focal, through F prime. We're going to draw straight lines through the origin and beyond, and what you notice is that these are parallel lines. So what happens here is that objects which are at the focal length, they end up focusing at infinity. This is especially useful for a lighthouse. You can put a light bulb here and it'll shine a light that doesn't spread as far as it'll go before it just runs out of energy. All right. Now, an object at infinity will focus at the focal point. So I've got my lines coming in here from infinity. That's why the focal point is the focal point, because it's where objects focus. This is how a magnifying glass works. If you want to burn dried leaves, like I used to do whenever I was a kid during the summer, you take your magnifying glass. The sun is effectively at infinity. It's not actually an infinite distance away, but for our intents and purposes of our lens, it's like it is. So all that light energy coming from the sun, if you can find that focal length, that certain length at which you hold that magnifying glass up above the whatever you're trying to burn, paper, grass, dried leaves, then once you find that focal length right here, that's where that energy is going to be focused. That's how you can use a magnifying glass to burn leaves. If you haven't seen a video of that or done it yourself, get a chance to or try to. It's fun. Don't start any fires. All right. So on this one, let's see what happens if we place an object inside the focal length. And I want you to make the focal length for this one a little bit longer than the other. So we're going to put 8 squares here, maybe like 3 or 4 inches, another 8 squares here, same on the other side. And we're going to put the object 3 squares away and 3 squares tall. All right, so now I've got it between F and the origin and the lens. As before, and this one's complex, so pause when you need to. Draw a line from the tip of the arrow through the origin. You see that there. Next, extend the lines backward in the same line using a dotted line, like I've done here. Next, draw a line straight from the top of the object to the origin. You see that. Pause as you need to. And then continue that line from the y-axis through the focal point on the other side of the lens. There it goes there. And then we're going to continue that line backwards as well with a dotted line. What we're up to is we're going to make a virtual image. Then we're going to draw a line from the focal point through the top of the object, like this, from the focal point to the top of the object, and then go straight back. All right? And you see how they all converge right here? We're going to form a virtual image that is upright and magnified. Again, virtual because you can't project it on a screen. Magnified because it's bigger, and upright because it's the same orientation. Take out some more graph paper. Let's do another. Now we're going to try outside of 2F. If I've got 5 squares here, 5 squares here, maybe like 2.5 inches, 2.5 inches, let's try it at 13 squares. All right, so we got our object. If you're working with graph paper, let's make it 3 squares high. If you're working with a ruler, maybe 1 inch high. Same as before, from the top of the axis, from the top of the object to the y-axis, down through the focal point. All right. From the top of the object through the focal point down to the y-axis. You'll notice it doesn't go nearly as far down this time. And then straight out. And then right through the origin, and they should all meet up at the same spot. When you've got an object with its light passing through a thin convex lens and it's outside of 2f, it's going to end up between f and f prime and 2f prime. It's going to end up smaller, that means reduced, and it's a real image. We can project this. As I'm looking at my screen right here through my glasses, my screen has got to be smaller to fit on the back of my retina. So my eyes are taking some object at greater than 2f for the lenses inside my cornea, right? Not to mention the lenses on my face here. And it's reducing that image down so that way I can see it on my retina and my brain can process that imagery. All right, so again, real meaning you can project it on a screen, or like light's being projected on my retina. Reduced because it's smaller. If you measure this, it will be smaller in size. And if you've done your drawings correctly, you'll see that smaller size, and it's upside down. Okay, what if we put our object between f and 2f? All right, so set up your graph paper again. Get all your measurements correct. Same as before, to the y-axis, down through f prime. Okay, down through f, and then straight out, and then going across. And what you should find is that if your original object is between f and 2f, its position will be farther beyond 2f prime. It will be larger. You can measure these and see that this is larger, and it's inverted as before. Again, that's real, magnified, and inverted. All right, I think we've already been through these. I'm going to pause and jump up to what's going to be most useful. All right, so this is a file that I'm going to upload for you. This is the top half of the supplemental aid I usually have my students use at the end of second semester for their ACP, Assessment of Course Performance. You'll notice you've got your object outside of 2F, an inverted, real, and reduced image, an object inside of 2F, and it's going to create an inverted, real, and magnified image. Object at 2F creates an object the same size that's inverted and real at 2F prime. An object inside of the focal point is going to go through this complicated process to make a virtual image. That means it can't be projected onto a screen. That is the same, that's upright instead of inverted, and it's magnified, meaning it's bigger than before. Object at the focal point focuses at infinity. This is useful for searchlights. And object infinity focuses at the focal point. That's why it's called the focal point. Okay, so you can make use of this to answer the questions you need to about lenses and image formation. Any questions, let me know.